Hi everyone, today we are exploring operating system generations, how they are evolved over time, and the fascinating system boot process that powers your computer when you turn it on. Let's dive in. Firstly, myself Kaushik, currently a second year student at SVCE. In this video, we will explore the evolution of operating systems, their types and generation, how the system boot process works, key technologies, modern trends, and the future generations. Now let's start with the basics. What exactly an operating system? It's a software layer that acts as a bridge between the user and the hardware. Without an OS, your computer would just be a pile of components with no way to interact with them. The OS manages the resources like memory, storage, and the processing power, making sure everything runs smoothly. The key components of an OS are include the kernel, which handles the core tasks like memory and the process management, and the shell, which, which is what users interact with either through the command line interface or with the graphical interface. Operating systems can be categorized by their functionality like single user OS like Windows for personal use and multi-user OS like Linux allowing multiple users to work simultaneously and real-time OS used in critical systems like robotics and aviation where even a millisecond delay could be disastrous. Think of an OS as a conductor of an orchestra. It ensures every instrument plays at the right time to create a harmony. The evolution of operating systems can be divided into five distinct generations, each reflecting significant advancements in technology and the user needs. The first generation of operating systems, spanning from 1940s to 1950s, they didn't actually have operating systems as we know them today. Early computers like ENIAC and UNAVAC were manually operated with user inputting instructions like punch cards or paper tapes were used. Programs were written in assembly language or machine language, making them incredibly difficult to debug and time consuming to execute. And the second generation computers are emerging in the 1950s and 1960s. They introduced batch processing systems. Tasks were grouped into batches and processed them sequentially, significantly improving the efficiency compared to the manual operations. Magnetic tapes were replaced with punch cards as they are more significant and efficient in storage medium, and the computers like IBM 1790 led this era. And the use of transistors in hardware made these machines faster and more reliable. The third generation, spanning from 1960s to 1980s, they brought several groundbreaking features. Multi-programming allowed multiple programs to reside in the memory simultaneously, ensuring better utilization of the CPU. Time-sharing systems enabled multiple users to interact with the computer real-time through terminals. Innovations like spooling overlapped input or output operations with computation further improving the efficiency. This era also saw the development of the virtual memory and operating systems like Unix, which became a foundation for many modern systems, and IBM System or 360, which introduced a concept of a general purpose computer. And in the fourth generation, starting from the 1980s and continuing till today, operating systems became more friendlier with the advent of graphical user interfaces like GUIs. This marketed the rise in the personal computers, making technology accessible to the general public. Networking capabilities were integrated into the operating systems, enabling the local area networks and eventually the internet. Microprocessors drove down hardware costs and storage technology advanced from the floppy disk to hard drives and SSDs. Key systems from this era include Windows, Mac OS, and Linux, each playing a significant role in shaping the computer landscape. And the fifth generation represents the present and the future of operating systems. Modern operating systems leverage cloud computing, AI integration, and distributed computing to deliver unparalleled performance and scalability. Containerization tools like Docker and orchestrations platforms like Kubernetes are transforming how applications are deployed and managed. Real-time operating systems now power IoT devices, and early research is exploring operating systems for quantum computers, Mobile operating systems like Android and iOS dominate smartphones, continuously innovating to enhance user experiences. This evolution showcases how operating systems have transitioned from basic manual controls to advanced and intelligent platforms that power everything from personal devices to global cloud infrastructures. Now let's move on to the system boot process, one of the most crucial process that happen every time when you turn on the computer. And the definition of booting is the initialization sequence that prepares a computer for use is called as system booting. And the types of booting are the cold boot and the warm boot. And the goals of booting are test and initialize the hardware, load the OS kernel into the memory, and hand over the control to the OS for user interaction. Now let's look into the detailed steps which are involved in the system boot process. It all starts with the POST, power on self test, when you press the power button of your computer and the BIOS or UEFI firmware wakes up the hardware and checks that everything is functioning properly like the CPU, memory and the storage. Once the hardware is verified, the firmware searches for a boot device. This could be your hard drive, SSD or even a network drive. The key is that the system looks for a bootloader, a small program that's responsible for loading the operating system. The bootloader then hands control over the OS kernel. The kernel is like a brain of the operating system. It initializes the hardware devices, memory, and other critical components. Finally, the system starts essential services and you are greeted with your login screen. Now let's look into the key technologies in the system boot process. Modern operating systems are evolving rapidly and some exciting trends are shaping the future. The first cloud-based operating systems like Chrome OS are changing the way we use the devices. These systems are rely on the internet for most operations, making them lightweight and efficient. The next, there is AI integration. AI-powered operating systems can predict user behavior, optimize the performance, and even troubleshoot problems automatically. And another major trend is virtualization and containerizations. Tools like Docker allow applications to run in isolated containers, making deployment faster and more efficient. Hypervisors like VMware enable multiple virtual machines to run on a single physical machine, making maximum resource utilization. And let's not forget edge computing, where the real-time operating systems handle data processing on IoT devices, reducing the latency and enhancing the performance. These are the key technologies in the system boot process. Now let's talk about some technologies that making the modern trend in the OS booting so efficient today. BIOS versus UEFI. BIOS is a old firmware limited in features like storage capability, and it's gradually being replaced by UEFI, which is faster, supports larger storage devices and also has advanced features like graphical user interfaces and mouse support and a secure boot. This is a security feature found in the modern systems. It ensures only trusted software like verified OS is loaded during the boot process, protecting against malware and rootkits. And the bootloaders like grub for Linux or a Windows boot manager are vital for loading the OS kernel. This allow you to dual boot the multiple operating systems, which is a greater for tech enthusiasts. And to sum up, operating systems have evolved from basic manual systems to AI-powered platforms that run on the cloud. Each generation has introduced groundbreaking innovations from batch processing to time sharing and now distributed computing. The boot process, which initializes your hardware and loads the OS, is the foundation of this entire journey. Modern technologies like UEFI and system boot make this process faster and safer and more efficient. And the future is bright with the trends like AI, containerization, and edge computing redefining what's possible. Understanding the operating systems and the boot process isn't just for tech enthusiasts, uh, it's essential knowledge for everyone curious about how their device work.